How it's made. Drone. Drones have undoubtedly become more than a novelty and are produced today to cater to mass needs. People tend to neglect the fact that these little flying machines have just become part of our lives these days. From security purposes to shooting films and videos, drones today have evolved to something that's worth admiring. By studying drone design methods and materials, you can understand how this remarkable technology has developed so quickly since the dot-com boom and how it will progress in the coming years. In this video today, we take an in-detail look at how the small piece of technology is made. From designs, working, to manufacturing process, you'll learn everything in this video, so make sure you watch till the end. Hey guys, and welcome to another interesting video from How It's Made. Before jumping into the video, if you are new here, please consider subscribing to our channel. Also, hit the bell icon to get a notification whenever we upload a new video. That said, let's begin. What is a drone? The drone is a particular type of small unmanned aerial vehicle, UAV, a multi-rotor or multi-copter. As the name implies, these machines fly by directing thrust downwards from two or more motor-driven propellers. Whereas the most popular consumer model is the quadcopter, 4 rotors, but the commercial variants include the hexacopter, 6 rotors, and the octocopter, 8 rotors to provide greater lift. To be precise, there is a wide variety of military and civilian drones out there, but we'll focus on common multi-rotor drones and the materials from which they're made. To fly, the drone must be able to generate enough upward thrust to overcome its weight. Therefore, the choice of drone material is dominated by minimizing the mass of the drone. Every gram of material used to make a drone requires energy to lift, and every gram that can be saved improves performance. Raised cargo volume. This process of selecting materials and designing components to minimize mass is called lightning. This provides the most important selection criteria for material properties. It is to choose a low-density material to minimize mass. The analysis for each part. A drone is a complex device in which various components work together. Because each component performs a different function, various considerations are involved when choosing the right material for each part. However, for each part of the drone, material density should be considered to minimize weight and maximize performance. Frame. Keep it all together. The frame gives the drone its shape and keeps all the subsystems in place. The most important material property of the frame is strong, as it performs a mechanical function. Besides, for commercial drones, thermoplastics such as nylon, polyester, and polystyrene are popular choices because they can be inexpensively manufactured into complex parts using an injection molding process. What is a drone made of? A drone frame. Thermoplastics also offer good strength and low density, with some varieties with a tensile strength above 100 MPa and density below 2 grams per centimeter cubed. Thermoplastics have become a popular component of experimental drones, as many thermoplastics are also available in filaments that can be used to 3D print aftermarket parts. However, commercial drones can sacrifice some additional weight for a more affordable price, while industrial drones prioritize performance. Since a small amount of high-strength material can be used, it becomes a lighter and high-performance drone. To be precise, the material with the lowest density and the highest strength will only be found in the carbon fiber reinforced composites that are the best choice for high-performance drone frames. These composites provide high strength, low density, and high rigidity to create lightweight, rigid drone frames. Motors and propellers. Lift. The motor that drives the drone is a conventional electric motor with copper windings and permanent magnets. Motor housings can be selected to minimize weight, and either thermoplastics or aluminum alloys offer excellent strength-to-weight ratios. However, the motor can generate a lot of heat. Therefore, a material with high thermal conductivity, such as aluminum, can be used for the housing to keep cool the motor. Drone rotor blades rotate at high speeds and therefore tend to absorb the most wear when the drone flies or collides. As with the frame material, choosing the best rotor blade material is to maximize strength while minimizing weight. Some rotor blades are made of carbon fiber reinforced composite. However, because rotor blades are frequently damaged and replaced, they are often made of thermoplastics, reducing replacement costs in the event of damage. Rotor blades are usually damaged by high-speed impacts during rotation, so engineers looking to design durable rotor blades can filter the material by impact strength and density to select the right material. Battery. Flying power. Of all the components of the drone, improved battery technology could be the most important breakthrough that enabled the latest multi-rotor drones. Battery performance can be measured by battery weight in the same way that strength-to-weight ratios are taken into account when designing mechanical components. Measures such as specific energy and specific power represent the ability of a battery to store and release energy in terms of battery mass. Old lead-acid batteries and NiCd batteries were too heavy for drones that powered them to fly for long periods, even if they could lift themselves off the ground. However, the latest lithium-ion batteries provide enough energy and power in a lightweight package to enable today's multi-rotor drones. Future advances in battery and condenser technology will enable even lighter, higher-performance drones. Sensor, drone's nervous system. Multi-rotor drones make subtle balance adjustments with each flight. If the thrust of one motor is too great, the drone will tilt or tip over. Just as the human body uses a complex network of senses and nerves to balance walking, the multi-rotor drone stays in the air with an impressive set of sensors and feedback mechanisms. The most important part of the drone's nervous system is its tilt sensor. A tilt sensor that combines a gyroscope sensor and an accelerometer is tied to a feedback loop with the drone's motor. In-flight drones constantly fine-tune the thrust of the motor to keep it level and recover from airflow and extreme maneuvers. Some advanced drones can also tilt each rotor individually, allowing the drone to control both the direction and strength of the thrust it receives from each rotor. Drones can also use a variety of other sensors to monitor internal systems and the world around them. Current and voltage sensors help the drone track the energy drawn from the reserve power and help the pilot know when to land and recharge. GPS and magnetic sensors assist navigation by measuring the position and orientation of the drone. Airflow sensors allow the drone to detect airspeed or wind flow and feed that information back into the balance circuit to further stabilize the drone's flight. Microcontrollers and cameras for smarter drones. The same advances in microchip technology that created modern smartphones have made it possible for drones to become in-flight computers. Many of the same chips found in smartphones are also found in drones. As drones get smarter, they have less human control and can take on more sophisticated tasks. Currently, this means that drones can follow a given path without a human pilot and record measurements from an array of larger sensors. However, researchers are learning how to program drones to perform increasingly complex tasks without human help. For most people, the overall purpose of a drone is to carry the camera to a height that humans cannot otherwise reach. Even basic consumer-level drones have cameras that broadcast video to smartphones or record images in memory. Movie studios use high-end drones to shoot high-budget movies, but advances in the field of computer vision are turning cameras into more than just payloads and assistants for human pilots. Future drones will use cameras to see the world around them and use that information to steer themselves. Drones are now able to fly without the help of human pilots or GPS, creating powerful new features. Drones work together. Drone swarms used to consist of a team of drones that use GPS to communicate with a central controller to determine where each individual would fit in the group. However, state-of-the-art research has produced drones that use their onboard sensors and even cameras to recognize other drones and fly in formation. Soon, it may become common to see teams of autonomous drones acting as lifeguards, caring for crops, and flying search teams to support disaster relief efforts. World-influence technology. Drones seem to be everywhere now. They're filming movies, starring in movies, supporting real estate sales, broadcasting sports, creating new sports, working on farms and factories, hunting other drones, and could deliver packages soon. As materials, AI, and microcontrollers improve, drones will continue to revolutionize a wide range of industries. The future of drones. As stated earlier, drones are becoming popular, revolutionizing the way people work and play around the world. The materials used in the drone are selected to improve performance with a high-strength frame and high battery capacity while minimizing weight. By minimizing the weight of the drone, its performance can be maximized while the cinema drone can perform longer shoots or making a race drone even more maneuverable. As a result, they're constantly getting smarter and are becoming more in use. So that's it, guys. Let us know if you found this video informative in the comments section below. Also, if you like this video, give it a thumbs up and share it with your friends, and don't forget to subscribe to our channel for more such amazing content. See you in the next video.